This is a cuboid down here. What we have here is called a cuboid, and this cuboid can be cut into two equal right angle triangular prisms like we have here. Let's say we get our saw, and this is our cuboid with dimensions length, breadth, and height. Now we can use this saw to divide this cuboid into two equal right angle triangular prisms. Now I call this, let me write it, right angle, let me write that out, right angled triangular prisms. Now I call these these two solids triangular right angle triangular prisms, because we say this is a prism because if you notice here we have one end here. This is an end here, and if you check here also we have another end here, and you notice these two ends they look the same. They look uniform. So this is called a prism because it has a uniform cross-sectional area. This portion here that you see, this portion here, this top surface here is called a cross section. This portion here is also called a cross section. So you notice that the two cross section are the same thing. So this solid shape here, this right angle triangular prism, has a uniform cross section. So this is called a prism. Prism. So if you look at this also, this has an end face here. This also has an end face, and these two end faces, let me bring this out. These two end faces are the same thing. So we'll call this, we'll say this shape has a uniform cross section. So this is also called a prism. Now we say a cuboid can be cut into two equal right angle triangular prisms like this, and we can easily find the volume of one of these right angle triangular prism. What we'll just do is, now you will know that the volume, we'll just say volume, let me use another color for this. We'll say volume of prism equal to, now if you check here, the volume of this cuboid will be volume of cuboid equal to the length, let's say the length, times the width, that's the width here, which is represented by b like breadth. Width and breadth is still the same thing, times the height, Height. Now so we can just write this as length times breadth, which is still the same thing as width. So length times breadth, which is still the same thing as width, times height. Now if the volume of this cuboid is length times breadth times height, now this prism here, this right angle triangular prism here, is just half of this cuboid. That means the volume of this right angle triangular prism here will be 1/2 length times breadth times height. If the volume of the whole cuboid is length times breadth times height, it means the volume of the right angle triangular prism will be half of the volume of the cuboid, and also this one will also be, the volume of this other one will also be half of the volume of the cuboid. This should be length, let me just put times, or instead of putting times there, let's this be length times breadth times height. Okay, so we'll just say that the volume of this prism, the volume of this triangular prism, will be 1/2 the length times the breadth times the height. That's going to be the volume of this right angle triangular prism. And you notice we have the height of the prism, this right angle triangular prism, as h here. The height is just the distance between the two cross sections. Now you know this is the first cross section here, the upper surface here is the first cross section, this other part is the second cross section. Now the distance between the two cross section is the height. Sometimes we call it the thickness or the length. Let me just write that out. Call it the height, Height, the length or the thickness of the prism, So That is that. So the volume of this right angle triangular prism is 1 over 2 the length times the breadth times the height. But from this we can also do something here. Now you know, for this base face here, this is a triangle here. Now the area of this triangle is 1 all over 2 length times breadth. You know, this is definitely, this is the area of this triangle here. This is the length, this is the breadth. So this is the area of the triangle. So from here we can just say 1 all over 2 length times breadth then times height here. So 1 over 2 length times breadth is the area of one of the end face, area of end face times the height, height. So for the volume of any prism, let me write that well. For the volume of any prism, the volume of any prism is given as area of one of the end face times the height. Let me just put this like this. Area of one of the end face times the height. And this is one of the end face. This is one of the end face. So I'll just find, so to find the volume of this prism, now what I'll just do is just find the area of this face, then multiply it by the height or the thickness. This height here. This is the height here also. So I'll just find the area of one of the end face, maybe the area of this portion. That's one of the end face. Then multiply it by the height, and I'll get the volume of the prism.